One final point I want to talk to you guys about the electron structure and its configuration is to do with what happens to the electron structures of atoms and compare it with ions. And you should be able to see that there will be some similarities of some atoms and ions depending on what it is. Now, let's take a look at some electron structures out there. So here we have fluorine as an example. It has 2 electrons on the first shell and then 7 electrons on the second shell. And it so happens that the energy content of this overall atom of fluorine is not as good if it can occupy a noble gas configuration. Now, what is a noble gas configuration? Well, for IGCSE, a noble gas configuration is when atoms will become ions to achieve this noble gas configuration, and I'm using neon as an example. The noble gas configuration is when the outside shell has the maximum amount of electrons that that shell can hold. So for IGCSE, that noble gas configuration would be 8, except for helium, which is 2. Now, neon here has 2 electrons on the first shell and 8 electrons on the outside shell. This outside shell is known as the valence shell. Okay? And the electrons on the valence shell are called valence electrons. Now, energetically speaking, all atoms want to transition to a much lower energy level. Why? Because it wants to use as much energy as possible in order to maintain stability. And so a lot of atoms out there, in fact all the atoms out there, with exceptions to the noble gases, all the atoms out here are going to gain or lose electrons or share electrons in order to achieve this noble gas configuration over here. So here we have sodium, and it has 3 energy shells because it's on the 3rd period. It has 2 in the first, 8 in the second, and it has 1 right there on the top, on the outside shell. It has 1 valence electron on the valence shell. Now, it so happens that when fluorine isn't going to be happy being like this, it wants to achieve a noble gas configuration. And in order to do that, it should accept an electron from somewhere else, or share the electron from somewhere else. All right? And when it gets the electron from somewhere else, you would see that its electron structure will now look exactly the same as neon. And so fluorine, which is now fluoride, has the same electron structure as neon. If we were to draw the electron configuration for neon, it will be 2,8, and the electron configuration for neon will also be 2,8. Sodium. Now sodium wants to achieve a noble gas configuration as well. But it turns out it takes a lot of energy to take in 7 more electrons. It is easier for sodium to give out that electron. And when it gives out that electron, it loses the shell. And voila, inside sodium, the charged sodium, which is a sodium ion, a cation, will have the same electron structure as neon. That's amazing. And its electron configuration will be exactly the same as neon. So, when you have these things out in nature and in isolation, these ions and atoms which will look exactly the same because we can only see the outer shells and we can only see what's outside and not really what's inside the nucleus. We could find other methods to do that, but that's not the point of it. The point of this is to appreciate that ions form or even share, or atoms share electrons to achieve a noble gas electron configuration and electron structure.